Hi, in this video I will be adding and subtracting rational expressions with unlike denominators. Notice we start by finding the LCD, or the LCM, of the denominators. We rewrite each fraction with the LCD, and then we'll add or subtract our numerators. Remember, we keep our denominator the same, and we always want to make sure we simplify our answers. So on number 1, our LCD is 12. We'd already done this earlier. And so we want to rewrite each of the fractions with a denominator of 12. Well, to change 3/4 into a fraction with a denominator of 12, I need to multiply this 4 by 3. So to make it legal, I multiply the numerator by 3 as well, and I get 9/12. So this is what we call building fractions. Basically, we multiplied by 3 over 3, which is equal to 1, and that's what makes it legal. Multiplying by 1 doesn't change the value, but it'll help us to write the fraction with a different denominator. So doing the same thing here, I need 6 times 2 to get the 12, so I'll multiply the numerator by 2, and I get 2/12. Now notice 2/12 is the same as 1/6. 9/12 reduces to 3/4, so these fractions are equal to what we started with. But now we can subtract because we have a common denominator. So 9 minus 2 is 7, and so we get 7/12. All right, so you might want to stop the video and try number 2. It's very similar. All right, let's see how you did. So again, we talked about this earlier. I'll just go ahead and do it. You start with the bigger number here, and 15, and you look at the multiples of 15 until you find one that's divisible by 12. Well, 15 is not divisible by 12. Neither is the next multiple of 15, which is 30. We'll add another 15, we get 45. That's not divisible by 12. And finally, you get 60, which actually is. 60 divided by 12, you'll get 5. It actually goes 5 times. And so 60 is our LCD. And so we'll multiply by 5 over 5 to get that 60 in the denominator. So again, we're trying to rewrite these two fractions so they have a denominator of 60. So here we need to multiply 5 times 5, which is 25. 15 times 4 is 60. So we want to multiply the numerator by 4, and we get 32. And so if you add those together, you get, what's that, 57 over 60. And that's number 2. On number 3, our LCD is going to include any algebraic factors we find, which we found x in both. And the highest power we found is x squared. So notice I don't multiply these together. I take the highest power of x that I found. And so that's going to be my LCD. So I need to rewrite the fractions so that they have that denominator. Now the second one already does, so I don't need to do anything with that one. And if I want to change x to an x squared, I need to multiply by x, which means I'll multiply the numerator by x. So 5 times x is going to be my numerator. Of course, x times x is the x squared. So now we can subtract our numerator. We get 5x minus 3 over x squared. All right, so you might want to try number 4 and then watch the video. All right, so here you should get an LCD of 24x. The LCD for 6 and 8 is 24. And you want to make sure you also include the x factor. Notice we don't multiply the x's, we just take the highest power that we find in these denominators, and that would be x to the first. So our new denominator needs to be 24x. And so we're going to rewrite these fractions with that denominator. So here, 4 times 6 will give me the 24. So I'll multiply the numerator by 4, and we get 20. Here we need to use 3 to get 24x. And so we'll multiply the numerator by 3 and get 21. And so 20 plus 21 is 41 over 24x. And so those are done. Let's go ahead and move on to the next problem. I need to adjust my camera. Let me go ahead and focus it just a little bit. Okay. So in this case here, our LCD would be, well, first of all, x plus 5 has to be treated as a single algebraic factor. If it were 5x, we would use the 5x to find the LCD, but it's not. It's x plus 5. If I knew what x was, I would know what x plus 5 is, but I don't. So again, I'll treat this as a separate algebraic factor, and the same thing here. So my LCD can be found by just multiplying the two together. Alright, so let's go ahead and rewrite the fractions with this LCD of x plus 5 times x minus 3. Alright, so in this case we're missing the x minus 3 factor. Notice I like to put parentheses around any binomials that I multiply by. So here I'm multiplying by x minus 3 times 4. So 4 times x minus 3. Over here I've got the x minus 3 factor. I'm missing the x plus 5 factor. And so let's multiply by x plus 5 over x plus 5. Now you got to be careful here because you are multiplying a single term, a monomial, times a binomial. You do need this in parentheses, and you are going to need to distribute. So let's go ahead and add our numerators. And I'm just going to write LCD on the bottom just to save a little writing until we get to the end. So we'll distribute here. We get 4x minus 12 plus 7x plus 35 over our LCD. And so finally we're ready to combine our like terms. You got a 4x and a 7x, which is 11x, and a minus 12 and 35, which is 22. Oh wait, 23. 2 from 3 is, or 2 from 5 is 3. So plus 23. Our LCD was x plus 5 times x minus 3. Now I do want to point out something that we discussed in class. You could certainly multiply this out and write your answer that way, but you can also leave it in factored form, which we tend to do, so that you can see that there's nothing we can do to simplify this further. Alright, on number 6, this denominator, actually both of them can be factored. You can factor out a 4 here times y plus 2. And here you can factor out a 5 times y plus 2. And so our LCD is going to include the LCD of the numbers. Well, for 4 and 5, it turns out that 4 times 5 is your LCD. It's 20. You can look at the factors of 5 until, or the multiples of 5, so 5, 10, 15, 20. It's not till you get to 20 that you find one that's divisible by 4. And so it's going to be 20. And then we have an algebraic factor of y plus 2 in each denominator. They're both to the first power, so we don't need to multiply them. We just need to write one factor of y plus 2. Okay, so let's go ahead and set it up so that we can see what our new denominator needs to be. Let's see, you might hear my washing machine, so just don't be surprised. Let's see, so here the only thing I need to do to change this denominator to be our LCD is multiply the 4 by 5. So we'll multiply by 5 in the denominator and 5 in the numerator. Kind of got to ignore that 6 there. So it'll be 5 times y minus 2. And then here, you're going to multiply by 4 to get 4 times 5 would be the 20 here. You already have the y plus 2 factor. So we're going to multiply by 4 over 4. And again, let's put the 4 in front, and let's put the y plus 6 in parentheses. So we're going to get 5y minus 2. I'm going to go ahead and distribute there. But to be careful here, I'm just going to subtract the numerator. Now you could have done this in one step, and I'll just put LCD here. So this becomes 5y minus 2. A negative 4 times y, that's minus 4y. And negative 4 times 6, that'll be a minus 24 over your LCD. And so finally you get 5y minus 4y, which is y. Negative 2 minus 24, that's going to be a minus 26. And you know what? I just realized I made a mistake. This should be 10. Right? 5 times a minus 2. Did I mess this one up too? I sure did. Or wait, no. No, that one's good. All right, so we have 5y minus 4y, that is y. A negative 2 and a negative, oh, that's not, let's change that to the 10 we said. Negative 10 and negative 24 is going to be a minus 34. And since we're in our final answer, we won't write LCD, we'll actually write it out. You should always write the final answer complete. So it's y plus 2 times 20 here. And so that's your final answer. All right, let's move on and look at number 7. Now to save time, I'm going to go ahead and factor this using the AC method. Basically, x times x is the x squared, and I need two numbers that multiply to negative 20 that add to negative 1, and that would be a minus 5 and a plus 4. And so this is the factorization of that. So you can see our LCD will include all the algebraic factors that we found. Well, we found an x minus 5 and an x plus 4. And this other denominator doesn't add anything new that we hadn't already found. So that is our LCD. We use each algebraic factor found to the highest power found. And so that's going to be our new LCD, or I should say our new denominator. Now notice for the first fraction nothing changes. It already has that denominator. But for the second one, we'll need to multiply x minus 5 times x plus 4, which means we'll multiply the 2 in the numerator by x plus 4. So again, we're multiplying by something that's equal to 1. That's what makes this work. All right, so once we have a common denominator, we can add our numerators. We're going to have x plus 2x plus 8 over our LCD. And we can add the 2x and the 1x to get 3x. And don't forget about the 8. And that's going to be over x minus 5 times x plus 4. Oops. Let's move on to number 8. You might want to give it a shot. It's going to be a little bit more work because you're going to end up foiling on twice. So here our LCD is going to be x plus 3 times x minus 4. So that'll be our new denominator. Sounds like the laundry's ready. Let's see, so we have x plus 3, we need to multiply by x minus 4. So we'll do the same thing in the numerator. Again, we're basically multiplying by something that's equal to 1, x minus 4 over x minus 4. So we're going to have x minus 4 times x minus 2. So here we're going to multiply by x plus 3 to get this denominator. So we'll do the same thing to the numerator. You can see I like to write all my binomials in parentheses because this is where we're going to FOIL. So here we have x plus 2 times x plus 3. So now we got to FOIL all this out. You could do it on your own on the side, but I'm just going to go ahead and write what it's equal to. We're going to have an x squared, a minus 4x, and a minus 2x, so that'll be a minus 6x plus 8. And then over here, when we multiply, we'll get x squared. We'll have a 2x and a 3x, so 5x, and plus 6. So again, I know that was kind of quick, but you can always do that multiplication off to the side. Do your 4 steps. And that's over our LCD. So we're going to add all this together, x squared minus 6x plus 8 plus x squared plus 5x plus 6. When we're adding, we don't really need parentheses. You could put them in there, around 3 terms here and the 3 terms there, but we would just subtract them, or drop the parentheses next anyway. So that's still over the LCD. So we have a 1x squared and a 1x squared, which is 2x squared. We got a negative 6x and a 5x, which is minus x, and 8 and 16, 8 and 6, which is 14. Our LCD was x plus 3 times x minus 4. Now the only thing left to do here is make sure that this doesn't factor. It actually doesn't, because it is possible that one of these factors would be in common with what we have here if this factors. And so notice the AC would be 28 here and B would be negative 1. The numbers that multiply to 28, 1 and 28, 2 and 14, or 4 and 7. Since they multiply to a positive, they're either both positive or both negative. Since they add to a negative, they must both be negative. And notice nothing is going to add up to negative 1 there. And so this is a simplified answer. The numerator does not factor. All right, last problem, number 9. So here our LCD. Now be careful, it's not this times this times this. Y squared minus 4 factors as y minus 2 times y plus 2. And so if you look at all that we've got here in our denominator, we've got an algebraic factor of y minus 2 and y plus 2. And this is adding nothing new. We already have those 2 factors. None of these factors are to anything other than the first power. And so the highest power of any of them is just to the first. And so we don't need to, like we have 2y minus 2's, we don't need to put a square here. They were both to the first power. And so that's how we write our LCD. There's no powers on either of those. Okay, so now we want to make sure each of our fractions has y minus 2 times y plus 2 in the denominator. Now notice the last one already does, and so I don't have to do anything with that one there, because we already have the denominator that we want, the LCD. Now here we're missing the y plus 2, so we'll multiply the numerator by y plus 2, so we get 5 times y plus 2. Here we're missing the y minus 2. So let's go ahead and just put it behind. You could put it in front or behind. So we're multiplying by y minus 2 over y minus 2. We're going to get a minus 2 times y minus 2 over y plus 2 times y minus 2. So now we have a common denominator. We have 5 times y plus 2 minus 2 times y minus 2 plus y plus 3 all over our LCD. Let's combine our like term. Well, actually, we need to distribute first. So we'll distribute here. We get 5y plus 10 minus 2y plus 4. And then don't forget the y plus 3. That's still there over our LCD. So finally, we can combine all our like terms. We have 5y minus 2y, which is 3y plus 1y. We get 4y. We've got 10 and 4, which is 14, and another 3. So 4y plus 17 over our LCD, which is y minus 2 times y plus 2. And that is our final answer. All right, that's it for this video.